everyone. We're back for the third speaker in the series. We have Haleyanne Freedman. She's the market manager and engineering consultant for AM at Holland Company. And she's here to talk about 3D printing in 2020, opportunities and obstacles. I'll leave it to you, Haleyanne.
Thank you. Let me get my screen sharing set up here. All right, so first, what I want to do today is introduce you to just who M. Holland is, to give you a little bit of a background. So M. Holland is a family-owned company that's been serving the plastics industry for over 70 years. So we are the largest plastics distribution company in North America. So we're heavily embedded in the injection molding space and the plastic processing space. And so for myself, I'm a full-blown 3D printing nerd in my career and personally. This is my home office collection of 8 3D printers. But I have direct experience on over 65 different 3D printing technologies. I've become really an expert in the application conversion from injection molding specifically over to additive applications. I've worked with hundreds of different companies of all sizes through their adoption of 3D printing. And I don't know, I just have a full background in 3D printing, and I like to tell people I really don't have any other hobbies. So that's a little bit about me. So M. Holland and 3D printing. M. Holland entered the 3D printing market about 3.5 years ago. And it was a really interesting space for the company to enter because, you start to compete with, whether or not this application should be 3D printed or if it really should be injection molded. But that really gave us a unique position to be genuine, unbiased consultative experts in the space. So what we've done in the last few years is we've developed a full-blown portfolio of materials. We now carry over 250 different materials for filament, for SLS, and for photopolymerization. We have approximately 4,000 plastic injection molding customers, all with applications for 3D printing. And we offer full-blown consultations. We do a ton with machine evaluations and figuring out what types of machines people should be using for different applications. So it's a really fun place to work if you like to play with different 3D printers and find out what they're particularly good at and where their strengths are. So the challenges and limitations of 3D printing. So there's a lot of nuances within the industry. There are misinformed machinery purchases. There's a lack of genuine education of the overall industry and of the design concepts. There's a high cost of materials still within the 3D printing market, and there's a lot of there's a massive lack of proven and truly certified tested materials for applications. So if you're in the industry, I'm sure you have heard that a million times. The need for UL blue carded materials and the need for ISO certified materials are significant, and they really have inhibited the adoption of additive overall over the last several years. And there's also a lot of unrealistic expectations of the technology. At least 10 times a week, we get emails saying, I want to produce a part that has the exact same properties as an injection molded component. And that's just physically impossible. You can't get a part that has identical properties in 3D printing as a different process. The only way to do that is to use the same process. So there are a lot of unrealistic expectations of the technology still out there. And then there's a whole nother layer of that. There's a misunderstanding of the different methods and their requirements. Photopolymers are a whole different ballgame if we're talking about thermoplastics, completely different properties, completely different ways to modify them. And then there's, SLS and all of those different requirements. Each process has their own design constraint. And there's also a lot of miscalculation of the initial investment costs. So when I used to work on for printer manufacturers in the past, what we used to do is say, your part would cost $4 to print if you only consider materials. And that's not your only cost when we're talking about overall additive adoption. And so there is a lot of misconceptions as to how much it truly costs to create a 3D printed component. And there's also a lot of misconception as to how 3D printing can fit in the process. So I want to speak to that a little bit as it pertains to plastic injection molding specifically, because I think that's a really unique area to talk about. So with injection molding, there's high volume applications where we're making 3 million plus of components, and then there's low volume applications, so custom molding or high variable components. And some people think that we're trying to go after these million a year components, and we're not. That's not really where additive fits. we're trying to find those low volume production applications where it truly makes sense from a costing standpoint, and fit that into a molder's process. So a lot of times, if they're a large molder, they will reject that project or that job if it's too low volume for them to be able to do viably. Or we've even had customers that have completely lost their low volume business because it's already been transitioned over to 3D printing in another way. So we really want to try and help those molders compete and stay current with the different plastics processing technologies, so that they can understand exactly how to fit that into their existing processes. So as it pertained to COVID-19, there were a lot of opportunities. COVID has, in my opinion, been a little bit of a blessing to the additive industry because it really gave us an opportunity to show where this fits in manufacturing. So I'm sure you've seen the million news stories that have been out for the last year about the 3D printed PPE. There were hobbyists and manufacturers alike printing face shields. You know, I was printing face shields at home. We were printing face masks and face shields at our headquarters. People were producing the ventilator components with SLS and MJF technologies. And we really saw the issues with these distributed supply chains where there was an issue getting these components from international countries when there were all these shutdowns. And we all experienced every single manufacturing industry across the board. And it really gave 3D printing an opportunity to shine. So some missed opportunities with COVID. There was a lot of a lack of education around the capabilities and the availability of machinery. So 3D printing, 3D printer sales completely soared during COVID. People were buying them personally. Companies were trying to invest so that they could contribute. And that led to a lot of overinvestment. We had a lot of customers who were really taking their time to evaluate the technology and then rush to purchase a machine. And then when we looked at it, it was just the complete wrong machine for their company and for their processes. And it started to restrict them. And, you know, closed platform, while I do believe that that has its place in the 3D printing industry, it really limited the participation because of the material availability. Material developments that happened in the last year were on open platform because they wanted to make it available to a large variety of printers. And if you had a closed platform printer, you weren't able to participate in some of those applications because you didn't have access to those different materials. And the limited material selections. So even when we were looking at, you know, how do we make these face shields, PETG was the best option that we had available. There aren't a lot of medical grade materials. You know, there's a handful, but the existing solutions are either very cost prohibitive or they lack the necessary certifications to truly be used in those applications. So that really, really hurt the industry at that point, but it also sparked a lot of development and prioritized a lot of material development for the industry as a whole. So those certifications are just so important. And I feel like I talk about that in virtually every presentation that I give because it's a difficult process. You know, to get those certifications requires the certifying body to understand the technology, to potentially redesign their certification a little bit so that it can actually adhere to the process as they need to be able to evaluate those technical requirements. But there just aren't very many, and there's not a lot of people who are willing to invest that time and the expense in getting those materials certified. But I do believe that we're going to see a change in that over the next couple of years. The unrealistic expectations of technology, you know, like I was saying earlier, it's not genuinely comparable to an injection molded property unless you do a lot of work on property validation and figuring out exactly what your property translation is. And there's a lot of industry misinformation as well. And that really, really harms widespread adoption. And, you know, I say that and it really is a bold statement, but there's so much misinformation about 3D printing out there. If you Google 3D printing, I'm sure you'll see 9 articles on the first page that just aren't true, or they aren't truly reflective of what the technology is capable of. And while those things might be really cool to talk about, they're not genuine examples of how we should be using the technology. And so in my opinion, it really does harm the overall adoption of the industry. Another thing that we've identified as a materials supplier in this space is that there is a ton of inaccurate technical data in the industry. So we get all of our different materials, we get the supplier technical data sheets in our hands, and then we run all of our own tests. We've just approached it saying, we want to validate everything. We want to make sure that we are providing our customers with the information that's genuinely accurate. And we found major discrepancies across the board. And that's just because there aren't true standards for the testing. And there's a lot of room for error and the reporting of unusable or inaccurate information. And that's widespread. And that really, really harms whether or not these are able to meet the production requirements, and if you can even validate those materials enough to approach production as a whole. So the technical data shortcomings. So the lack of the testing standards has completely enabled the inaccurate data distribution. A company could take 100 tensile tests, average out the results and report it in different orientations. And, they might include that in the fine print, but that's not, accurately reflected if you're doing a side-by-side comparison. Orientation can be overlooked and isn't always adequately understood by those using it. If you're new to 3D printing technology and you don't understand exactly how the anisotropy of these parts computes to your properties, then you don't really know that maybe that technical data was taken in the perfectly optimal orientation of that tensile bar, and you're going to be printing your part and it's going to be loaded into different axes that aren't going to achieve that same result. So that's a big miss in the industry, and I've seen a little bit of that change with some of the suppliers that we work with. They're starting to test things in different orientations and report that, but it still leads to a lot of misunderstanding and not true reflection of the technical properties of these materials. So this is a comparison that we ran. So we have a full-blown laboratory in Easton, Pennsylvania that runs our tensile tests. And so on the left, and I'm not gonna call out which material this was by any means, but this was a supplier provided technical data sheet. And you can see the differences are pretty significant in the tensile data, and we ran significantly more dog bones. We ran them in different orientations because that's truly how you should be evaluating, specifically for FDM, how you can use these materials and how you can use these applications. But the discrepancies are very significant. Not one orientation, even the ideal orientation for printing in this material, achieved what they were reporting. And that's a consistent problem. That's something that the industry has to do better if we want to contribute to the overall adoption of the industry. We can't do it with this type of data. We just can't. So in aligning our expectations for plastics, 3D printing is not a replacement for high volume molding applications, and it's not intended to be. I hear a lot of people saying, oh, eventually it's going to get cheap enough where we're going to be able to make 5 million of these a year. But that's not where we need to be focusing. We should totally be focusing on how we can bring down the cost of even the low volume applications and reducing those material costs as a whole, because where this fits is in situations like COVID-19, where we had a completely cut off supply chain and there weren't enough masks and there weren't enough face shields and there wasn't enough equipment, and 3D printing stepped in and was able to produce those within a few days. It was only 5 days before several thousand face shields had already been produced in the US when the country shut down. And that was significant. That's where we should absolutely be focusing all of our efforts. But that doesn't mean that we should be not investing in those certifications and that technical data testing for those materials, because that's just as valuable. Those low volume applications are just as important as the high volume applications. And this enables a lot of customer specific manufacturing, which is where a lot of the industry of plastics is going. So 3D printing is really not optimal for all traditionally manufactured part geometries. If you work in 3D printing, you already know that, but we go through that every single day. If you have an injection molded geometry, you might have a degree or two of draft on your part, and draft is the enemy of FDM, and it's just not necessary on those parts. And so there are some parts that just aren't able to be made. We still try to push customers, if there are possible geometry changes and it's a flexible geometry, to try and allow us to modify those whenever possible. But sometimes that's not an available solution. That's not always what we're able to do with those applications if it's a geometry that has to be certified. But wherever we can do that, that is the ideal situation. And as I said before, and I'll say a million times, the 3D printed parts do not have identical properties to injection molded parts, and they never will. We want to get as close as we possibly can, and we can get 90% of the way there in some circumstances, but just dispelling that expectation that it's going to be identical is incredibly important for the furthering of this industry. So as the 3D printing industry, what our responsibility is to understand that the misinformation harms adoption. And this is where I feel sometimes the marketing and engineering teams and at some of these companies might be fighting a little bit, because the misinformation and saying, okay, well, this is the best tensile result that I got when I tried it 100 times, even if it wasn't the average and it's not accurate, putting that information out there helps no one. It might get a molder or a customer interested on the very, very front end, but the moment that they try to trial that application and it doesn't reflect those properties, that application discovery is over, and it really discourages companies from continuing to investigate additive applications because it wasn't reflective. It makes it hard to trust it as a true manufacturing method, and it really, really hurts the industry. So if you do work in additive and you're in that situation, I would encourage you to, push that point within your company, because it just has to be talked about more. We've got to stop saying that this is possible when it's just not. Report the data as it is so that we can evaluate applications and find the real fits, because that misinformation is a true waste of everyone's time. The adequate testing standards are also required. If we don't say that they need to be tested in these orientations and these tensile requirements have to be reported in a certain way, it's just too easy for them to be able to say that this is what I tested it at, and these are what's possible. I've even seen technical data sheets from suppliers that are completely physically impossible. Like, even if they injection molded that dog bone and coated it and everything you could possibly imagine, there was no way that it was going to be able to achieve those results. And again, that lack of standard is a major, major problem, because we're letting people get away with reporting those standards as opposed to providing some element of regulation around that. We need to educate for realistic expectations. Within the Holland group, our policy is we want to say yes more often than we say no, but we're always realistic with it. We would never, ever tell a customer that they should 3D print an application when it should truly be molded. So when we educate for the realistic expectations, as opposed to trying to force applications to work with 3D printing that really shouldn't, that's how we're going to find the perfect and ideal fits for additive and further the true adoption within the industry. And my last point is that additive companies are incredibly protective of their IP, and for good reason. IP is worth protecting, absolutely. But when we're talking about something that's still in development and still being researched heavily and trialed all the time, we've got to be able to collaborate. When companies are so focused on protecting their secret sauce, we don't get enough collaboration and communication between companies to really understand how this could work. We've got a lot of ideas and information that we get from our customers that we would love to be able to share with some of these companies and contribute to their development. And fortunately, we've got some great relationships with some manufacturers.
Hi there. It looks like we might have lost Haleyanne for a minute. Let's give her a few minutes to come back. She's still sharing her screen, so I'm not sure what's happened with her video. Okay, so we're just trying to get Haleyanne back. I think she just needs to refresh her connection, and then we should be able to resume right where we left off. We've got 9 minutes left, so go ahead and if you haven't taken a look yet at the Q&A, oh, there she is. So take a look at the Q&A and upvote anything if you want to have her answer those questions. Haleyanne, I'll hand it back to you.
Isn't video conferencing fun? Oh, okay. Anyway, so diversification for molders is truly imperative to the survival. I'm not sure where it cut off, so if I'm repeating myself, I apologize. But if you're an automotive molder and that's the only component that you manufacture and the only industry that you cater to, if that industry suddenly drops off, you aren't able to compete or survive anymore. So we've seen a lot of molders looking for ways to diversify, and we've been offering 3D printing as a potential solution for them to be able to capture customers that are in that low volume space that might enter them into other industries. We've also found that 51,000 companies had at least one key supplier in Chinese provinces that were impacted by the coronavirus outbreak. I think everyone was impacted. We were impacted. The whole company was impacted. All of our customers were impacted, but that was very, very significant. I think we saw a lot of issues in our supply chain strategies as an industry as a whole because of the issues highlighted by the coronavirus. Digital manufacturing is also the future. I think we're starting to find that, we don't have to be in person for everything. This was really hard the first couple of months, but it's easier to be able to communicate virtually and to do these things. And, even when I'm working from home and our laboratories in Chicago, we're able to do digital manufacturing seamlessly because it's just file transferring. And I can send every single thing that needs to be done into the programming of the printer in just a file to our lab technicians or any of our engineers, and they're able to produce that. So that's a huge advantage that we've been able to utilize over the last year that we knew about, but it wasn't as heavily used because we were, working in person. And the last is, companies cannot develop products based on empty promises and inaccurate data. I know I'm repeating myself, but if you are an additive company and you're a material company, report accurate data. Companies will not develop products with your materials if they do not understand exactly how it's going to perform to the best of everyone's knowledge. So we need to be able to focus on accurate data, genuine education, if we want to be able to further the adoption within the industry. So industry benefits. 3D printer sales soared as communities stepped in for PPE production, and 3D printing is no longer viewed as a fad. I've been at Holland for about 3 years, and my first year I felt was spent just trying to let everyone know that this is not going away. This is a viable manufacturing method, and I don't really fight that battle anymore. We've had customers coming to us asking us constantly, how do we get into this? What kind of printers do we buy? What type of materials are available? How do we position this within our company? Because they understand that this is a very serious manufacturing method and deserves to be regarded as such. The technology has totally proven its place in manufacturing, and it's not going to be ignored anymore. Printers are getting better, materials are getting better. It gets better every day. We get articles in our emails every single day with something new that a company's come out with that's a major discovery for the 3D printing industry. And looking forward, the data is key to the industry expansion. In my opinion, that is the biggest piece that the industry needs to be able to overcome in order to further the adoption. Those extended data sheets that test it in multiple orientations and under different conditions are the best existing way to evaluate this. As we develop additional tools and tests, I think we'll find some better ways to evaluate it, but that's the best way to do it today. So if we make that the standard and we demand that of our suppliers and we demand that of the material companies, that's the only way to make that happen. But those absolutely need to be utilized prior to qualification if we want to get that application from start to finish. And like I was saying before, 3D printing is no longer a fad, and we don't have to fight that battle as severely anymore. So that is my presentation. That's the information I had to share. If there are any questions, you said that there is the Q&A section. Is that correct?
Sorry, it takes a while for me to pop up. So there's Q&A. We have from David Moss. What is Holland's role in AM? Raw polymer material supplier, filament supplier, or what?
All of the above. So when people ask what we do in 3D printing, it's really hard to put into even a paragraph, let alone like a 7-page booklet, because we do everything. We have access to all the raw material stocks with all of our suppliers on the plastic injection molding side. We work closely with the chemical companies to give them our feedback and test their materials and help them bring products to commercialization and market. We work with the printer manufacturers. We work with the customers. We do everything. So we do supply materials into the marketplace. Like I was saying, we distribute filaments, photopolymers, SLS powders, and then we also have the raw feedstock in our M. Holland portfolio with our dozens and dozens and dozens of raw material suppliers.
There we go. Great. So another question that had quite a few votes. Are 3D printed plastic parts able to be recycled into material for use in injection molding? If yes, how widespread is this practice?
I am so excited to answer this question because we have a huge sustainability initiative with M. Holland. It's very, very important to us. And so we've actually done a couple of things. So yes, they can be recycled for that purpose. However, because they don't have markings, you don't want to recycle them through your standard, recycling processes. And it's actually really expensive to go through the existing 3D printing component recycling programs. We were looking into it when we first started our sustainability initiative, and it was like $55 for a tiny box. And with my own printers, like I just recycled like 22 spools and a whole bunch of different prints. So what we found instead is to keep those within the ecosystem. We have recycled material suppliers that we work with. So they will either use recycled ABS pellets to make us filament, and then we can recycle that material in the 3D printing ecosystem. Or if we understand exactly what that base polymer is, and it doesn't have to be the same supplier when it comes to materials like PLA, and ABS is a little bit harder because when you mix different base ABSs, it can be more warp prone and pretty garbage material, to be honest. But PLA is a lot more flexible and friendly to being combined with other base materials. And so if you know that that's PLA, then you can re-chop those parts back into pellets and use those for injection molding, but they have to be specified. So we do have a program for that. So if you're looking for places to recycle those, please reach out to us, because we had to just do it ourselves. We tried to find a way to do it with, existing companies, and there just wasn't enough. But without those markings, it's hard to define that base polymer because we don't know what it is unless you're super into plastic and you can pick something up and know it's made of PLA.
Great. Well, I think that's all the time we have for today. Thank you so much, Haleyanne. You've got so many great comments in the chat. So if you haven't looked at it yet, go ahead and look at the comments in the chat. A lot of people really were digging your presentation. So thank you very much. And hopefully we'll see you around later today in the networking.
Yes, absolutely. Thank you very much for having me. I will talk to you later.
Bye.